Hello and welcome to the Kielder Observatory podcast. I'm Ian Brannan and I'm joined by Director of Astronomy at Kielder Observatory, Dan Pye. And it's been an award-winning month for Kielder Observatory. Find out why in a few moments. And our special guest this month is Dr Robert Massey, Deputy Executive Director at the Royal Astronomical Society. We'll find out more about the society that's been running for over 200 years now, and also some of his own thoughts about the universe.
I think it would be really interesting to know how the universe is going to end too, and how long that would take. I'm pretty optimistic it's a very, very long way off, but I'd go with wanting to know the fate of the universe too, I think.
All to come here on the Kielder Observatory podcast. First of all, let me introduce Director of Astronomy at Kielder Observatory, Dan Pye. And your job title seems to expand every month, and your job title this last month expanded to include not only Director of Astronomy, but also holder of awards, because Kielder Observatory has won a very prestigious award. Tell us about that, Dan, because you were there, you were gathered, you were part of the team that went along to the awards. Tell us about what it is that you've won.
I was, yeah, and it's fantastic to have won the award. We won the Gold Award for Small Tourist Attraction of the Year at the North East Tourism Awards, which there was an awful lot of competition in there, and some really, really great venues as well. Woodhorn Museum is a fantastic museum, and they were in our small business category, as was Usher as well. And it was great to win the gold in that category. It makes it all feel so worthwhile, working so late at night and entertaining people 7 days a week, and all the work that the team put in. I'm incredibly proud of the team for doing what they do and upholding the standards that we set. So yes, fantastic to have won such a prestigious award.
So Kielder winning the small attraction category, and then, of course, there was the larger category as well for some of the larger venues and names. But this puts Kielder alongside some well-known names in North East tourism, doesn't it?
Yeah, it does. The large visitor attraction of the year this year, gold went to Alnwick Garden. Which arguably, not that I'm trying to say that anyone is better than the other, but Alnwick Garden is probably one of my favourite places to go in the North East. I really love Alnwick Garden. And they cleaned up actually at the awards. They won 3 awards that night. Against some really big heavyweights. I mean, Beamish Museum were in there. Beamish, you would think, my gosh, Beamish, being against Beamish in a category must be such a daunting prospect, because, of course, such a famous and long-established tourist attraction. But Alnwick Garden, yep, they swamped the large visitor attraction this year, and 2 other awards as well. Experience and something else, I think it was. I can't remember.
And this award, just tell us about it, because whilst you've got the actual award, the process of winning it was such that some people came along and you didn't know that they were award judges, and they had the full Kielder experience, and they've reported back, and you've won the award, which is tremendous. But real stamp of approval, though, for anybody who is planning to come to Kielder Observatory or forming their list of things to do in the North East over the coming months in spring and summer, then you know that coming to the Kielder Observatory is going to be a top quality experience.
Yeah, it does, and I think that's the thing when you're looking to spend money, particularly on an experience. You need to have confidence in that experience that you're going to have a good time. And albeit that stuff can be subjective, depending on who, of course, goes and what their desires and likes are. I think just having the recognition to say that we've been vetted by a group of judges, we've been mystery shopped. We didn't know when they were coming, and they just turned up. They didn't reveal themselves to us at all, and then we should win this award. So it is a real stamp of approval, almost like the whole hotelier thing, where you would go to a hotel and the AA have turned up with their recovery truck and stuck 3 stars on it or something like that. I'm not sure if that's actually what happens, but but it is a stamp of approval. It gives people confidence to part with their money and know that they're in safe hands coming to us, and we're going to do everything that we can to give them a good experience, and that's hopefully what people will have when they do come and visit us.
And if you would like to come and visit us, then you can get your tickets, kielderobservatory.org. Have a look at the sessions that are available, pick one, and get your tickets to come along, because we're limited to how many people can come along to each session. Many of them are booked up for the immediate few weeks, but looking at May, June, July, and through the summer, there are plenty of sessions available. So do have a look at that, and we'll talk more about that in a little while. Right now, let's have a look at what's going to be happening in the night sky over the coming weeks as we head into April. Of course, spring has sprung and the clocks have gone forward now, so things changing in the night sky. But what can we expect over the course of the next few weeks into April, Dan?
It's actually quite a difficult couple of months for observing, really, without a telescope, and that's because a lot of the stuff that's really interesting to see at this time of the year is quite deep objects. We're looking at things like galaxies, the big clusters within Virgo, where we've got, I mean, you can spend an entire night almost in a region in the constellation of Virgo. We call it the Ball of Virgo. It looks like a big bowl in the sky, and you can literally point your telescope in that direction and just move it around and point it towards little blobs of light, and each one of those blobs of light is a galaxy in itself. So it's a real exploration month for deep sky objects is March into April and such. So not much bright stuff on the horizon other than, of course, the moon, which is very bright and such a pain to us all.
Yes, it can steal more than its fair share of glory. Easter holidays are going to be happening in April, of course, but over the next few months, May and June, we've got more bank holidays and, of course, the weather getting better. Maybe people planning on maybe thinking of ways that they can get their kids involved in astronomy as well. And you have some special events that happen geared for kids, don't you? Just tell us about some of those events that are going to be starting up again.
So we're seeing the return of the Solar Quest, which is our summertime kids events that we do. And in these events, we look at the sun. Which is a great thing to do because, of course, the sun's out a little bit later, and so we can still look at it when those events roll around. So we're looking at things like the sunspots, because at the moment the sun is quite active, so we generally don't have a spotless day on the sun right now. So there's usually some sunspots that we can point our telescopes towards. We have these really great big solar filters that go over the front of our telescope so we can safely observe the sun, and it filters out something ridiculous like 99.99999% of the light from the sun, and you're left with this just glow of light when you can see little sunspots in it. And we did have another solar telescope, but it broke recently, so we're not using that this year, so we'll forget about that one. We didn't have it, just ignore the fact that I said that. And we also have our new radio telescope, which we can use to observe the sun as well. And there's some really cool, interesting little studies that we can, really very quick studies that we can do on the sun with our radio telescope, which hopefully over the summertime we'll be talking about more of how we can do that with the kids and with regular events as well. Towards the back end of April, it's probably worth mentioning that April is a really good month for meteor showers. We have the Lyrids meteor shower, which is coming up on the 22nd of April. And albeit that it's not a very active meteor shower, it is synonymous with very bright meteors. So it's going to need to be a bright meteor for it to cut through the moon, because at that time of the month, the moon will have just passed its full phase. So it'll be going into its waning gibbous state probably by the 22nd. But nevertheless, 22nd into the 23rd, that's our peak of the Lyrids meteor shower, big bright meteors that we often get with that particular one.
And the 22nd of April, just looking at my calendar, is Earth Day as well. So what a day to have a peak of
happy Earth Day.
Yeah, happy Earth Day to you. And then St. George's Day the day after. So
yeah, there's a constellation, dragon constellation. We've got Draco.
There you go.
Which is a dragon/snake, if you want to call it. I think it's a dragon.
Well, there's your link for St. George's Day then. That's all you need. Hopefully it's a clear night and you can see it. Now, our regular feature, Pie in the Sky, is a little feature that challenges the regular astronomer just a little bit. Now, I'm not sure the level of severity that Danny's going to come up with this month, but looking for something else in the night sky beyond the norm, just sort of test you a little bit. If you've got your binoculars or you've got your telescope, somewhere different to point it and see if you can see it. So here's Dan's little Pie in the Sky challenge.
And I like globular clusters because I think they're really interesting to gaze at, to think that these things, these objects, these are big balls of stars. If you imagine it just like you've got loads of stars and you've put them all really close to each other, and when you look at it, you can see this just ball of light. And this is thousands and thousands of stars, tens of thousands of stars, very, very close to each other, very gravitationally bound to each other. And they exist around the outskirts of our galaxy, usually hovering above and below the galaxy, quite close in towards the centre of the galaxy as well. And M3 is one of those structures. It's about 32,000 light years away from us, and they look spectacular with a pair of binoculars, or in this case you might need a little bit more of power with that. You might need to get something like a small telescope, and you might need to do it from a dark sky zone. It's just out of the alignment between. You could probably pinpoint it actually by using the two stars in Canis Venatici, and the Canis Venatici isn't a very big constellation. It is just two stars. And if you draw a line away from Canis Venatici towards the constellation of Bootes, down towards the very bright star called Arcturus, halfway between the constellation of Canis Venatici and Arcturus, you'll find M3. And it's a really cool globular cluster to take a look at. So that's my object of the month, M3, number 3 on the Messier catalogue. Let's go with that. In fact, actually, to make it easy for the next year, why don't we just do M1 all the way? No, we'll not do that. That's a bad idea. That's
you can't do the same. Can't go M1 in January, M2 in February, M3 in March.
Yeah.
I think we've rumbled the formula here now.
Yeah.
Okay, so that's the one to look out for then. M3, your challenge for this month on Pie in the Sky. On to our guest for this month then, and we're very pleased to welcome to the Kielder Observatory podcast Dr Robert Massey, Deputy Executive Director at the Royal Astronomical Society. Now, the Royal Astronomical Society was founded in 1820 and encourages and promotes the study of astronomy, solar system science, geophysics, and closely related branches of science. It has more than 4,000 members who are known as fellows, and one of those is our very own Director of Astronomy at Kielder Observatory, Dan Pye. You are one of those fellows.
It means I get to use the word, the letters FRAS after my name, which is always very exciting.
Wow, you've made it.
But I think it's an organisation which is absolutely riddled in history, and it allows you access to some absolutely incredible literature as well. Burlington House, which is the Society's offices, the library that they have there is absolutely extensive, exhausting the amount of stuff that you can go through there. So in terms of when you're doing research and when you need to learn about something very specific, the chances are you'll be able to access it through RAS. And I think it's really a great place for us to connect with other astronomy groups as well, because the RAS community is so vast and so wide. In particular, bridging amateur astronomy and professional astronomy, bringing them together, it allows us the ability to be able to access this almost infinite database of people who are RAS members and get an introduction to these people as well. So it's a great platform for connections, for learning, and of course flies an incredible flag for diversity and engagement in astronomy and geophysics and geology as well. So it's a great society which has been around for forever. Well, 200 years, so not quite forever, but forever in terms of the purpose of what I'm saying. Forever in my lifetime.
The Kielder Observatory podcast. I'm Ian Brannan. I'm joined by Director of Astronomy at Kielder Observatory, Dan Pye. And our special guest in this episode, for the rest of this episode, will be Dr Robert Massey, Deputy Executive Director at the Royal Astronomical Society. Welcome, Dr Robert. Firstly, can you just tell us a little bit of a potted history, really, because I know we're stretching the realms here, but it's over 200 years old, the Royal Astronomical Society. But tell us a bit more about the origins of the organisation and the kind of things that you're doing now in the present day.
That's always a challenge in a sort of 30-second soundbite.
I'd like to give you a challenge.
Exactly. Well, anyway, so it was founded in 1820 and in the style of the age by a group of gentlemen, and it was only gentlemen in those days, sitting down for dinner in a pub in London, which sadly no longer exists, the Freemasons' Arms, and they agreed. They had an illustrious company, included people like, William Herschel was our founding president, for example, but people like Charles Babbage were there and so on. And they agreed on the need to set up an astronomical society. And before that, I think the kind of only scientific society, it's not the older, there were others around, but it was the era that they were emerging from the Royal Society, which had pretty much done everything until that time. So you just have to imagine, I guess, as well, that all of the people doing that work would have been what we'd now describe as amateurs, wealthy amateurs, because they were rich enough to be able to afford to have their own equipment and do the science in their spare time, and perhaps in some cases after they'd already become wealthy through other means, but and so they're doing it almost full time, but they weren't professional astronomers in the way that we'd understand them today. And the society evolved over time, always reflecting this kind of central mission to advance the science, which also now includes space science and earth sciences to geophysics too. Have a more professional edge. And I guess, although, we do have a very strong amateur membership, I think about a quarter to a third of the members are amateurs, about a quarter outside the UK, but it has more of a focus on the professional science now. And that's also, of course, recognising the fact there are just so many, I can't remember what the count is, but there must be at least 100, probably 200 amateur astronomy societies around the UK as well. So what we do today is we still represent those sciences. Our central mission is still to ensure those sciences survive and thrive, but we're doing that for a whole manner of things, whether that's telling the world, the government, the powers that be, the media, the public, how great the science is, or running scientific conferences, publishing scientific journals. We maintain a brilliant library which has got lots of fantastic resources in it, including books from the 15th century. We have a first edition Principia and that kind of thing there. First edition Copernicus, the book from 1543 that he published on his death, demonstrating that putting forward rather the idea that the planets went around the sun. So that is a flavour of the kind of thing we do today. And we do things like this as well. We're happy to come and tell other people about our work and talk to people like yourselves.
And going back to the time when the society was formed, of course, the knowledge of the night sky, of the universe, was much different to what we have now. As you say, the equipment was obviously very, very basic. And you're talking about a time when the concepts of the universe were still being ironed out in many ways too.
Yeah, there's a huge technological change in the 19th century, I think, and you see massive advances in theoretical ideas in the 20th century, but in the 19th century what you see is a big expansion of the things we could do. So that's the century that includes things like understanding the spectra, the composition of stars, and also nebulae and so on, and pushing forward ideas for that. It's the century that sees the move to, the construction of these giant refracting telescopes and so on, studying objects like binary stars, trying to see them orbit around another, to weigh the stars for the first time. So what I often think about in the 19th century, and of course photography as well, that's an absolutely massive step forward as well. What I tend to think about in the 19th century is really so the toolkit was emerging that would allow us to really understand the wider universe. You see people like the Earl of Ross building a giant reflector in Ireland and mapping the spiral structure of what, at the time people didn't know were external galaxies, but trying to understand those. And because of the development of those techniques, it became possible to develop things like modern cosmology, where we eventually, putting those things together, were able to deduce that there were actually galaxies other than our own, and that the universe was much bigger than we thought it was. So I think that was really one of the big philosophical changes. I mean, you could carry on extending that into the last century as well, because of course things like radio astronomy, space-based astronomy and so on took off then. But the 19th century is very much an epoch of real advances in instruments and optics and being able to build bigger and bigger telescopes. And yes, we carry on that journey today, but I think it was the time that we went from it being a science where people relied on drawing and using large telescopes to starting to do what they would imagine at least were more objective techniques like photography, and the work of spectroscopy was a massive step forward as well, as I mentioned, being able to actually for the first time understand the composition of stars. I suppose there are other advances too, like measuring the distance to some of the nearest stars happened in the 19th century too. I think 61 Cygni was one of the first ones to be measured, and realizing they were actually light years away through the technique of what you do is something called parallax. You ride the Earth around the sun, essentially, as we all do, and you measure the position of the star in one time of the year, and you measure it again 6 months later, a tiny shift, but through that you can deduce how far away it is. All of those things happened in the 19th century.
And in the present day, when we consider the amount of distractions we have in our lives, and the amount of ways that we can spend our time, and no end of box sets to watch or computer games to play, that space still has that wonder, doesn't it? And maybe movies and sci-fi and things like that add to it. But for organisations such as the Royal Astronomical Society and for Kielder Observatory, this is a fantastic thing that people are fascinated by space and they want to find out more. They want to find out the facts, the actual facts of what's going on.
That's absolutely right, and that's why we expanded our kind of outreach work, our public engagement work, because we understand all that so well, and we get an array of fantastic speakers from the research community, people who can really convey their ideas to the public in that way. But I think you're right. The wonder of the night sky itself is something that inspires people, and you're very lucky in a place like Kielder, where you're relatively free from light pollution, to be able to get that kind of awe-inspiring moment for people. I think there's an enormous power in that. I was actually at a conference on light pollution in the last few days talking about that very topic. And I think even in cities, at least with the brighter objects, people still have that appreciation, because you're looking up above the kind of hustle and bustle below you, or the bright lights of the city or the streets around you, and you see something that's much more distant that you're aware is not part of your surroundings. And I suppose what's so nice is that, at least in some cases, with the moon and Jupiter and Saturn and so on, it's like transformational too. If you pick up even a pair of binoculars, you start to see that they're more than just. The moon obviously doesn't look like a point of light, but you start to see that they're more than points of light. So you realise for yourself that you get that experience of understanding we live in a bigger universe, and that we start to feel a little bit more insignificant as a result, which I actually find always quite refreshing. Actually, some people find it slightly daunting. I actually find it quite relaxing to know that I'm part of something much larger.
And on that subject, really, Kielder Observatory ourselves, we are part of something much larger. There are many observatories dotted around the country. Kielder Observatory, of course, in the Northumberland Dark Sky Park, so you get a particularly clear view of the night sky from our location. But from the Royal Astronomical Society's point of view, how important and what role do the smaller observatories play into the whole bigger picture of astronomy in the UK?
I think they're hugely important. I think if it's a rare science. Astronomy, in that sense, that it allows the public to take part in it so easily. I suppose there are citizen science campaigns around things. I don't know, like looking at insect life and bird life and plant life and so on. But the nice thing about astronomy is that it is so genuinely accessible that if you're lucky enough to have access to an observatory, and as you mentioned, there are a lot of them around the UK, if you seek them out, at least in the ownership of, say, amateur astronomers and so on, that can really help. But even if you only have the most simple equipment at home, or you just want to look up and start to see the constellations for yourself, you can take part in it. But to answer your question, I think observatories are great, and I used to work in one. I used to work in the observatory in Greenwich for about 8 years, and I saw for myself just how effective that was. Where I currently live in Bristol, we're moving fairly soon, but I live in Bristol. There's a fantastic astronomy society there. They've got an observatory out at Phelan to the west of the city. When visiting groups come and use that, they have scout groups and so on, guide groups, and other groups of young people, public evenings and so on. You can see for yourself just what a fantastic asset it is. I think it's a really great way of allowing people to experience the science themselves and value it without hard selling it. I think you mentioned earlier on that it sells itself. That's one of the ways to do it. If you get that awe-inspiring view of going out and look at, ideally, an unsullied sky, but even a light-polluted one, and you look at a magnificent object like Saturn and its rings, or the moon for the first time, which we should always remember there's a large number of people who've never looked through a telescope. They're absolutely blown away by sights like that, and it really does help build support for the science, and I think get people to think about the bigger questions too.
You're now the Deputy Executive Director of the Royal Astronomical Society, but how did your own journey begin in astronomy and in this particular science?
But no, I started off, as a child looking at the sky a bit, and had a small and not very good telescope bought by my dad, and used that a bit, and it wasn't entirely ideal. And then I actually joined a local astronomy society and found out more that way. And then I decided, just for the hell of it, to study it and do an undergraduate degree and then a postgrad degree and do research on objects in the Orion Nebula, the things that the Hubble telescope later imaged as forming planetary systems, before I moved on to become a teacher for a while. And then I had a career in public engagement for 8 years in Greenwich before I moved into my current role, where not my current role, actually, a previous slightly different role where I was doing kind of press work and some policy work. And whilst I still do that, I now manage our public engagement team as well. And and that's what I do as deputy director of the RAS. So I'm very much outward looking for the society, as well as having to get to grips with the nuts and bolts of it. So that's kind of the path I followed. So I do definitely have my feet in the research community as the thing that brought me into it. But now I try to do lots of associated work too. But I think certainly in my heart is very much still in I still have that feel about enthusing the public and the value of that being absolutely vital. And I think, Dan, you're right. I mean, of course, there are loads of bad nights as well for every facility, and that was definitely our experience in Greenwich too, was that we would go along and it would be cloudy or sometimes even raining and you'd be sitting in a dome. But even the fact of being there conveyed something special as well. And I think you're quite right too. I think that even if you're not able to see it for yourself, that if you're able to explain some of the fantastic concepts, even at the simplest level, just showing people stunning imagery from telescopes in space and on the ground, that can have a very powerful effect too. Perhaps because of people have seen those things, they, actually having someone talk through them and adding that level of depth makes a huge difference too.
Something that has made a huge difference into our knowledge of the universe is the Hubble telescope, and the Royal Astronomical Society have done a big presentation about this recently, which you can watch on the RAS website if you want to find out more about Hubble and its many years in space and the things that it's done, but also a comparison between Hubble and the James Webb telescope as well, which is another thing that we've talked about quite a bit, because James Webb is the new thing that launched at around Christmas time, and it's got components on there that were manufactured in the northeast. So we've spoken about that. There's little bits of northeast infrastructure heading into space. But the point in the presentation that RAS did really made the point that James Webb is not a replacement for Hubble. It's not the new Hubble as it's sort of been branded in some sort of news articles, but actually, it's its own thing. It's a successor. It's the next level on, but not a direct replacement.
That's very fair. I mean, I do some work with the steering group in the UK that looks after some of the public engagement work for this, and I think it's very fair. It's a successor to Hubble, which is not the same thing as being directly comparable. So it's going to take some of the science that Hubble did forward. And so, for example, one of the most iconic images from Hubble is of the deep field, which is a very, very long exposure of the distant universe. Basically, the scientists having the pretty smart idea of pointing the telescope at an apparently blank bit of sky. I think the longest exposure they did was something like 2 weeks when you added up the duration, and they found thousands and thousands of galaxies, which are very faint and very distant, and because they're very distant, it means we're seeing them as they were shortly after the universe formed. But there is a barrier, which is that if you want to see even younger galaxies, I mean, these are still big numbers, so we're talking about things that we can see at the moment that are a few 100 million years after the universe formed, after the Big Bang. But if you want to see back to the very first stars and galaxies, you need a telescope that can see redder light, because these objects we see are not only are we seeing them as they are in the distant past, but the universe, the expansion of the universe that we have today means that their light is shifted to the red. And so at some point that goes beyond the light you can see, red light, into the infrared. So we're familiar with that. We feel infrared on our skin when we go out in sunlight and so on. But to see it, you need a different kind of telescope, and that's what James Webb is about. The idea is that it will be able to see those, one of its targets anyway, is to see those very, very young stars and galaxies. So we might be able to, or we hope to be able to, with Webb in a few months' time, start to see the very first stars and galaxies that formed as they were, because one of the big great concepts in astronomy that I alluded to before is that telescopes are a bit like time machines, that the light takes so long to reach us that you're looking at things as they were in the past. I did vaguely have some fun with my daughter the other day by pointing out that we never see each other, even in the same room, quite as we are at that instant, because there's about 100 millionth of a second for the light to travel between us. And she was slightly surprised by that, and then looking around at different objects. But it was a nice exercise. I do recommend it. But yeah, so that's the kind of things that Webb will be doing. That's one of the things that we're most interested in. But of course, there's a vast amount of other science you can do. Infrared light is very good at getting through dust, so we can look inside clouds of gas and dust where there are forming stars and planets too, for example. And as you would expect, we're also very interested in finding the kind of worlds that will go on to be a bit like the Earth as well, and yet again trying to understand if there's life elsewhere in the universe. Not necessarily, probably not in fact discovering it with James Webb, but trying to find the kind of places it might be.
Yeah, and that is obviously a very big question. That's as long as perhaps there's been astronomy, that there's been that question of is there life elsewhere, and I think many astronomers do believe perhaps that there is in some form or another, and it's just a case of locating it. And exoplanets, I know, have been mentioned many times as perhaps being the key, or even if they're very, very distant ones, that they're likely to be where we are going to have our best chance of finding that. Is that a view that you share as well?
Yeah, I think there's life elsewhere in the universe. I wouldn't want to comment on how abundant it is or how common intelligent life is elsewhere, but I'm pretty sure it seems almost inconceivable there isn't some form of life elsewhere. I mean, it's one of those fields where you get tantalizing bits of evidence and not quite enough to say definitively whether it's there or not. So, for example, every time there's a new mission to Mars, it's generally the underpinning premise is, are we going to find some traces of fossil life on the surface? Wouldn't that be extraordinary? Obviously we've got the rover, usually a suite of rovers going around the surface of Mars looking for that kind of thing, and more to follow. And when we bring a sample back at the end of the decade or so, that'll be another thing to look for in the lab. Last year, we had actually it wasn't last year, it was the year before. Time's flying in the COVID era, isn't it? And I'm quite glad it's different now. But we had our big press briefing on traces of biomarkers, not life, but hints of biomarkers in the atmosphere of Venus, the specific chemical phosphine, led by a UK scientist, Jane Greaves in Cardiff, actually using radio data to find that, or submillimeter data, a particular part of the spectrum. And those kind of hints are what we're looking for, really, I think. So, if you went back 40 years, we didn't know definitively about any planets around any other stars, and now we know there are thousands. And then the next question was really, I guess, well, how common are Earth-like planets? So we've started to see some, not many, I have to say, but some in the data from observatories like Kepler that hint that we can't be absolutely certain because we haven't got all the data on them, but start to look like places that it might be possible to have life. And then the next question is to do more detailed studies, again, partly with telescopes like James Webb, but also with the big ones being built on the ground this decade, to look at the atmospheres of those planets to see if you see traces of the kind of chemicals we associate with life on Earth, or perhaps other indicative chemicals too. And it's this incremental quest. When you think about it, you think it's very easy to think aliens, coming here, landing on Earth. Probably isn't going to happen, is it, realistically? When you look at the distances and all the issues associated with that. But what we might be more likely to find is traces of life, either perhaps very simple life in our own solar system or on planets around other stars. And we'll be looking at the chemistry to understand that. Hints of abundant liquid water, the suggestion that there's an ecosystem that we can get a hint of at a huge distance. And then eventually, presumably, if we build even bigger telescopes, then we start to be able to not so much see the light, but see, image Earth-like planets. Perhaps that's something that will happen this century. I think that would be an extraordinary achievement. If there was one question that you could have the answer to now that you wonder about space, and somebody could reveal that, what would be your one question? Very good question. I mean, I would definitely go with are we alone in the universe? Absolutely. I'd certainly like to see that answered. If I'm going to stretch this slightly so we don't repeat ourselves, I think it would be really interesting to know how the universe is going to end too, and how long that will take. I'm pretty optimistic it's a very, very long way off, But I'd go with wanting to know the fate of the universe too. I think
I'm more interested in how it began. But I really enjoyed I can't remember who it was by, but there was a theory. Was it a couple of years ago? It was certainly within the last 5 years, where somebody suggested that the end state of the universe could be the potential similarity or bare similarities to the origins of the universe. Which that, for me, I feel quite comfortable with that. I'm quite happy with that. I'm more happy with that than things like the Boltzmann brain problem and stuff like that. That gets a little bit too abstract and weird for me, I think.
Understandably, really, yeah, I'm with you on that. That's true. The idea of lots of universes constantly budding off in some huge multiverse is you're right. It's strangely comforting in the sense you think that something is always there, so it does have a degree of being eternal about it.
It certainly stops the existential crises of wondering whether or not I am just a floating brain in the middle of absolutely nothingness. And that can really send off an existential crisis with most people, I think. What I find, for me, my experience of astronomy is that when I was a kid, I didn't think it was cool to take a step into astronomy and STEM-related subjects, and instead I went off to study media and then theatre. I don't know why I thought that was cooler. But I did. And so that's the route that I took. But now I feel like there's been a real shift in that. And I wondered what your experience is of that from a RAS point of view and a personal point of view as to how that dynamic's changed and how it feels cooler, if you like.
Yeah, that's fair. No, I think that's fair. And generally, if you have that strangers on a train conversation and you say you work in astronomy, even though lots of aspects of my job is not as exciting as people might think, actually, generally people want to talk to you about it. And they're interested, and they will ask you. I guess this is probably your experience too. They will ask you some big question. It doesn't matter who it is. If you're on a long journey and you get talking, that's the kind of thing that happens. And I think it has that status in science. Most, even a lot of adolescents who are otherwise not particular fans of STEM subjects will ask you the odd question in the right setting about it too. So I think it is something that tracks through the ages in a way that other sciences can find more difficult. And that's, I guess, a degree of coolness associated with it. I mean, obviously we've got media role models and so on. We've got people like Brian Cox and so on who particle physicists presenting astronomy, but doing it in a way that absolutely captures the imagination of a lot of people. And I guess, I don't know, there is something quite nice. We had that experience during COVID of people being able to look up at the wider universe and perhaps feeling that was quite a creative activity too. You see, with the advent of ever better smartphones, let alone really good photographic equipment, it becomes quite easy for people to go and take their own pictures of the sky and so on as well. And maybe that's helping drive it too. I also, there's a lot of work between artists and scientists trying to convey these ideas as well and trying to explore how they can be represented. And I think that can be a lot of fun as well.
Another thing that I spotted that's actually one of the articles on your website at the moment is talking about this Kepler 16b, which is an exoplanet that has been observed, but an unusual one in that it's orbiting two planets. So there's an article on your site about that, and that's obviously something different, and maybe something we'll see more of perhaps as James Webb starts delving deeper. And this is not James Webb that spotted this, I know, but as we delve deeper into the universe, maybe more of these rare quirks might start to come to light.
Yeah, I mean, that seems almost inevitable, right? You look at if you think about the number of stars in the galaxy, and if you sample enough of them, if you sample thousands and thousands and thousands, it would be odd if you didn't start to find these rare cases too. I mean, a big question for us, of course, is the Earth a really rare case or not? That's part of the whole question about life elsewhere. Are we living on a planet that just has incredibly special circumstances, and we were lucky enough that we're on it, that life was able to take root? But you're right. I mean, you'll be looking around. There will, of course, be binary systems are very common. I think that's right, as in most stars are binaries, so therefore it's not surprising that you find planetary systems around them. I mean, there is the caveat, which is that if the stars are they have to be either quite close together or they have to be very far apart, because otherwise it's very difficult to have stable orbits around them. But there are certainly plenty of cases where that's possible, and I think as we expand our data set, we are only going to see more of those. And there are more missions coming up as well as Webb and so on, whose job it will be to study and characterize planets around other stars. I have absolutely no doubt that we'll see these weird and wacky cases. It's good material for science fiction writers, if nothing else, as you get ever more unusual cases and circumstances.
I'm sure they're working on it right now in Hollywood. I'm wondering about light pollution, because at Kielder Observatory we have the dark sky park, really clear skies. But of course, in any city, that's not the same conditions for observing. And particularly, I'm thinking London, thinking of the Royal Observatory, and how it is, and how your view of the sky can be from really densely populated, highly light polluted cities, particularly that I guess that you find in abundance in London, but in the bigger cities in general.
And that's true in most cities and most suburban settings. I mean, you're absolutely right. And we're not directly connected with Greenwich. We share the city with it, and we've got good connections. But there are groups like the Baker Street Irregular Astronomers, who are a fantastic set of people who set up telescopes in Regent's Park, which is certainly not a dark sky site, but just has a nice level horizon, so you can go there and look at things. I think you just have to compromise. There's merit in this, because I think that I'm very much in favour of dark sky settings and trying to make sure that we ensure that places are preserved, and you get all these different designations, reserves and communities and places and parks and so on. But it's also really important to bear in mind that the UK is an urban country, and if we want to get this message out there, we need to encourage people in cities to enjoy the sky too, and perhaps to think about how they can make their own setting. Obviously not, it's never going to be as dark in the centre of London as it is in Kielder, but perhaps nonetheless starting to think about how we can control light pollution there too. On a different topic, it's also very good for biodiversity as well. There's a lot of evidence that excessive light is not doing our wider environment any good. And this conference I mentioned I was at this week, one of the contributors who runs a company called Dark Source, I think it is, it's a consultancy specializing in compliant night sky friendly lighting, pointed out that this is one of the environmental problems we can solve actually just by flicking a switch. Now, I'm being a bit facetious, we don't want all our cities to go dark overnight, but the point is that other things, there's an enduring legacy. This one, if we make an effort, we can probably make a real difference, and more quickly than in many other cases. And I think it would be fantastic if, not that we're not going to expect everybody, as I mentioned, in the cities to go out and see a pristine view, but if they had a nicer view, I can't see how that could be a bad thing for everything from the environment around us to actually our mental health as well, appreciating that there's something bigger than our immediate surroundings.
I think the cost of electricity as well encourages us all to switch the lights off.
Well, right now, that's a very appropriate message, isn't it? Quite.
And one thing that we should mention before you go, Dr. Robert Massey, is that you have a book out as well that people can purchase. It's not a new book, but there is a book. Tell us about that.
I know. Well, this is I realise people are listening to this. This is the book I co-authored with, I have to say it was her idea, Alexandra Loska, who's an art historian friend, actually a friend of my wife's, and because my wife is an art historian too. Moon Art, Science and Culture, if you haven't read it, is still available. And it basically takes some of the real gems of in fine art and in science associated with our nearest neighbour. So they're a really wonderful collection of images. I mean, I can't pick out individual favourites, but there are a lot of them, and as you would imagine, I help source a lot of the ones associated with science, but I also got in things like illustrations of the moon, many of the kind of ephemera associated with it, the way it's influenced us across society, and everything from fashion to food. So do take a look if you want to. It's published by Hachette and available online, at least at this point now, a couple of years after the Moonlanders. If you're ever at an event and we happen to be speaking there, we'll happily sign it for you as well.
Well, our thanks to our guest in this episode, Dr. Robert Massey, who is the Deputy Executive Director at the Royal Astronomical Society. And thanks to you as well for listening and joining us in this episode. If you're new to the Kielder Observatory podcast, well, please have a listen to some of the previous episodes. We cover all sorts of things. We recently spoke with Dr. Natalie Starkey, all about the volcanoes of the solar system. Dr. Olivia Jones, who is involved in the James Webb Telescope mission and was part of that launch team, and lots of information about what the James Webb Telescope can do. I know I mentioned it in this episode a little bit, but a full episode about that. And the other aspect of things in space, what about space junk and tracking satellites? Well, at Kielder Observatory, we've become the first place in the world to take part in a new project, which is tracking space junk and satellites, which is happening right on the hillside, right next to the observatory itself. Find out more about that project in a recent episode. And in February as well, we had an Ask an Astronomer special. So lots of questions from various people about different aspects of life, the universe, and everything. You can have a listen to that and many, many more episodes on whichever podcast app you use. Thanks again for joining us. We'll be back next month with another episode, and you can find out more about what's happening at Kielder Observatory on our social media pages, Twitter, Facebook, and Instagram. Search for Kielder Observatory. And indeed, you can have a look at our own website as well, kielderobservatory.org. All the latest news there as well. And of course, and crucially, all the information about the various sessions which are taking place at the observatory. Your chance to book your tickets as well. As I say, things fairly busy at the moment, but looking further ahead into the next few months, you might find some spaces. So go online and have a look, and we hope to see you in person soon. And thanks for listening to the Kielder Observatory podcast. We'll see you soon.